Let's look at the zero factor property. You guys have used this in solving quadratics for a long time. If two numbers are multiplied together and it equals 0, one of them has to be 0 or both. That's just the way it is. That is a property that we know about zeros. So what we're going to do now is we're going to use that property. If A is a real number that solves this equation, then there's three things that must happen. Either A is a root, which we've used before. A is a 0. If we graphed it, that's where it crosses the x-axis. A is an x-intercept. Those are the three statements that come from this. It is a root or a solution, it is a 0, or it is an x-intercept. And we've used those interchangeably, and you need to be familiar with those terms. Now this is asking for all the real numbers x for which this is true. So what we're going to do, since we're looking at this algebraically, is we're going to set it equal to 0 and use the 0 property that we've used before when we factor. So we factor out the x, 6x squared minus 11x minus 10. And now what we're going to look at is seeing if we can factor this. And let's see, factors of 10, I'm going to use 2x and 3x. And now if I'm looking at 10, if I put 5 and 4, that'll get me 11. So 5 here minus plus 2 over here. Negative 15x plus 4x gives me 11x. And so now what I have to do is solve each one of these. I set each factor equal to 0 and solve for x. We've done this many, many times. So here's this answer. 2x equals 5, x equals 5 halves. 3x equals negative 2, x equals negative 2/3. Those are my zeros. My roots, my solutions, my x-intercepts. So now what we're going to do is solve this one. And we're going to see how this works. There's a couple ways to do this. If I do x squared plus 4x minus 10 equals 0, it cannot be factored. So let's use the quadratic formula. We could use our calculator, but right now I'm just going to demonstrate the quadratic formula. Plus or minus 16 minus 4 times 1 times a negative 10 all over 2. Negative 4 plus or minus. So I have 40 plus 16 is 56 all over 2. Now that ends up being 4 times 14. So what I have here is negative 4 plus or minus 2 square root of 14 all over 2. And now if I factor out the 2, I can actually get negative 2 plus or minus square root of 14 over 2. And here's my final answer. Now one of the things we're going to do in Precalc is problem solving. It's one of those things that students really are frightened of, and they shouldn't be. We're going to do some practice examples all along the way. So whichever technique works for you, you need to understand what the problem is saying. So you need to read the problem many times. You have to know the terms, otherwise you don't understand what it's saying. Restate it in your own words. Identify the info that you need to solve it. And find the info you need from the data given. Now, info is obviously information. Develop a mathematical model. So you might have to draw a picture. You see me doing that. You might have to label the variables that are unknown. And from the sentences, see if you can develop some math equations with those things that are unknown. Step 3, you're going to solve the math model and see if it confirms your solution. So you either solve it algebraically and then check it graphically or numerically, or you solve it graphically and check it these two ways, or you solve graphically or numerically and not worry about the algebra. Interpret the solution. So did you actually answer the question? Those are some things that you have to realize. Just because you have an answer doesn't mean you answered the question. And check your units. Now this seems a kind of drawn out way, so I've shortened it. You need the problem, read the problem once, and you read the problem again. And then you write down your givens. G is for givens. And you write down what your unknowns are. See if you can make any equations out of this. See if you can substitute any information that you have in your problem and then solve your problem. Read it again. Did you answer the question? And are your units correct? I call this the guess way of doing it. You don't have to organize it that way. It just helps me to see it better. Let's try this problem-solving technique. Applying this to the process. The engineers at an auto manufacturing pay students 8 cents per mile plus $25 per day to road test their new vehicles. How much did the automaker pay Sally to drive 440 miles in one day? So let's write down what our givens are. We know they get paid 8 cents per mile. We know they also get paid $25 per day. We also know that she went 440 miles. So those are all my givens. My unknowns are I want to know how much they paid her. So the total dollar amount that she got paid. So let's see what equations we can come up with. Well, she starts off with, now you don't have to call it Y. I'm going to call it pay. We know that she gets paid $25, and then she gets 8 cents per mile. So $0.08. So this is dollars. This is dollars per mile. Times however many miles she went. Not minute, miles. So these units go away, and you end up with dollars plus dollars. So let's see what we have. We need to substitute in. This is her pay, 25 plus 0.08 times 440. We plug this in, and we get that she gets paid $60.20 for that day. Now, did we answer the question? Sure we did. We answered it because they asked how much she gets paid for that day. Part B says he earned $93 to test drive a new car in one day. How far did he drive? So this is kind of going backwards. We're going to use the same equation. He got paid $93. It was $25 for the day and 8 cents per mile. And we want to know how many miles he went. So now what I have to do is solve for this. So I get 68 equals 0.08x, divide by 0.08, and we're going to call it, I divide 68 by 0.08 and I get 850 miles. And that is the answer. Now we don't have to call it x. You could call this m for miles. X is not a magic variable. Now the next thing we're going to look at is graphing calculator. Our graphing calculator can have some misleading information. So we want to make sure we are smarter than the calculator. You have to ask yourself a couple things. Is the window appropriate? Is there a line, especially those of you who are using TI-83s? TI-84s corrected it, but the TI-83s show lines that may be asymptotes. In other words, if I have a graph that does this, and this is an asymptote, your TI-83 does not, it connects these pixels and it might put a line. Now that doesn't mean the line is there, it's just what the TI-83 does. It connects this pixel with this one. And so you have to know, is it really a line or is it dotted? And how accurate is the approximation that they gave us? So let's look if we can see a calculator failure. We're going to take this and we're going to put it on our calculator and see if there's an x-intercept anywhere. If you have a TI-83, it'll be hard to see this. So let me put the graph in the light. I'm going to go turn it on, clear, turn my plot off, and I'm going to put in down here 3 divided by, make sure you put it the bottom in parentheses, otherwise it will give you a wrong answer. And I'm going to push zoom 6 so that I have the correct graph. Now this is a TI-84, so notice there is no line here. However, if you have a TI-83, it will connect this pixel to this one. Notice at y equals 0, let's see if we can get to it. At y equals 0, we have a 0.6, or at x equals 0, we have a 0.6. So we do cross somewhere, but let's see if we can go to the table. Well, we got this table here, and you notice that this is where the y value is. But I want to know if there is anything near 2.5. So let's see what we can find. We got the 2 here. Notice -1, -3, and then we did a +3. Somewhere in here it might have crossed the x-axis. Go to table set, change this to 2.2, go by 0.01, and let's see what our table says. Now I've got negatives, negative, negative, negative. Let's see when we get to a positive. Still have negatives, bunch of negatives, bunch of negatives. And then I have an error at 2.5. So guess what? No intercepts. No x-intercept at x equals 2.5. And we could have done that with our domain. In other words, this cannot be 0. So when we solve for it, we get x equals 5/2, and that's what x cannot equal. So there is no x-intercept.